Okay, let's talk about geometry symbols. So if you're watching this video, maybe you are taking geometry as a full course. Maybe you're a high school student taking geometry. So that's excellent. Or maybe geometry is part of another math course that you might be taking. Or maybe you're just interested in geometry and you want to know something about symbols and notation used in geometry. It's really not that difficult. Here you can see on the screen, these are some notation and symbols. They always look kind of mysterious to people when they're first learning things, but really it's not that difficult. So what I'm going to do in this video is just introduce you to a lot of the more common symbols that we use in geometry. I'm not going to be able to hit every single one of them. So if I forget one or the other, again, this video is just to introduce you to these symbols, give some meanings behind this. So even if you haven't studied geometry, you'll definitely be able to learn from this video. So before we get going, let me go ahead and introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher, and over the last many years, I've constructed several online math courses to actually include a full, complete geometry program. So I'm going to leave a link to my math learning program below. Matter of fact, I'll leave a link to my full geometry course if that's what you're in. But if you really, need full instructional support for whatever reason, and you like my teaching style, then you might want to go and check out my learning program. Also, if you're new to my YouTube channel, I have hundreds and hundreds of math videos on my channel. It's been on YouTube for many years. So hopefully you'll consider subscribing. And if you like this video, please consider giving it a thumbs up. All right, so with that being said, let's get into geometry and symbols and notation. So here are some of the things that we'll talk about. But I'm going to make this kind of quick. I'm not going to drag this out because again, this is just to introduce you to some of these concepts, right? So we'll try to match a symbol, and I'm going to kind of do this in no particular order, if you will. Well, I'll try to kind of keep it somewhat organized in terms of basic geometry symbols and kind of like a little bit more advanced. All right, so what's the most basic thing in geometry? Well, it's like a point, right? So if I have a point and I want to represent that point in geometry, here's my little point. We could just name it A. Okay, so if you see a point and a little letter next to it, that's just point A. Now, what about a line? Okay, what if I have something like this? Right, so that's well, actually, this is a ray. Let me go ahead and actually draw a line. And by the way, here is a line, and this is a ray. So if you just look and see what the difference is, the ray here has a starting point. Okay, we call this a vertex, all right? And it's going in this direction, right? So it's kind of going, it's emanating from the vertex, going out this way, whereas a line is going in both directions. So this is what this would look like in geometry. So let's just put some points that are on this line. Let's say A and B are points that are on this line, okay? So this is what this would look like. But in geometry, we would write that as the line AB. Okay, so it's a little line with two arrows. You got to be very specific about the arrows like this, okay? Because you'll see here in a second that if you don't draw both little arrows, you're talking about something else. So let's say we have right here a ray, okay? Again, it's emanating from a starting point. Here, a line is going in, it's basically infinite in both directions, okay? There's no start or beginning, whereas a ray, there is a starting point, a vertex, okay? So this right here, we can kind of express this as ray AB. Let's just call it like so, AB, and the notation is a little thing like that, okay? So notice this one doesn't have the arrow to the left, it just has arrow in one way. So this is a ray, this is a line, they're two different things. Now, it can this could be confusing because we can have something that looks like this, right? Now this is kind of a piece of a line or piece of a ray. Call this a line segment. So let's say this goes from A to B. Okay, this is a very definitive starting point at any point. So this is a line segment, just a little segment of a line. And the way we represent this is AB with a little line over it. Okay, so here's a point. Here is a line. This is a ray. and this is a line segment. Okay, so some real basic things with lines, line segments, etc. Okay, so if you want to take notes, that's fine. You can, pause the video and write this down. I'm going to erase this here, but again, you can watch the video again. This is not designed to teach you all these concepts and details, just to get you to introduce you to the notation and symbology of geometry symbols. Okay, so let's go and erase this here. All right, and now let's talk about angles here for a second. All right, so here, of course, angles are a huge part of geometry, and here is an angle right there. So what's one way we can represent this angle? Well, there's a couple different ways we can do that. So an angle, all right, if you look at it, it's like two rays that emanate from this common point. This point here in geometry, we call this a vertex, all right? So that's a vertex point. But we can represent this, if you have points that are on this angle, okay, you can represent this angle in a couple different ways. So let's say this point A, our vertex is point B, and then we have another point C here, like so. So if I had 3 points, I can kind of draw this angle out. So to the notation to represent this particular angle, knowing these points that are on this angle, you just draw a little angle symbol, just like that. Here, let me do that a little bit better. Little angle symbol, and then we have to go A, B, C, all right? So this is angle A, B, C. Now notice the vertex is in the middle, all right? This is not a trivial detail, okay? So in other words, we wouldn't write this angle as angle CAB. You're like, okay, it's got a C and A and a B. This right here, this would be incorrect, all right? You always have to put the vertex in the middle. So another way you could write this is angle CBA. Okay, you can kind of go in this order, or you can go in this order. Probably it would be more appropriate to write it like so. Okay, so this little angle notation, very, very common symbol in geometry. So now let's go ahead and take this a step further. So let's say this guy right here, this particular angle is, let's say it's 30 degrees, all right? So if I wanted to represent that more formally using geometry notation, I could put a little m, okay, in front of my angle, all right, like this, and I could say the measure, that little m, okay, it stands for measure of angle A, B, C is equal to 30 degrees, okay? So very, very common notation. So when you want to give the measurement of an angle, you can write it like so. All right, so what are some other ways we can represent an angle? Well, there's other, you can just simply call this like 1, okay? So we could call this angle 1. Let me write that a little better. Angle 1, just like so, okay? Now let's leave angle 1 up there, and let's write or draw another angle, all right? And let's talk about angle 2. Now I'll try to, let's just imagine here for a second, angle 2 is the exact same measure of angle 1, okay? So we can say angle 1, all right, is equal to angle 2. But what we're really trying to express here is that they have the same measurement, okay? So the concept of what I want to get at is congruency, right? So when we want to kind of represent the exact same size and shape, okay, then we use this concept of congruency. I'm going to give you some more examples here, but the congruent symbol is the equal sign with this little squiggly thing over it like so, all right? So we can say angle 1 is congruent to angle 2, meaning that they're exact same angle. Now, if you wanted to be more specific, it could be like the measure of angle 1, it's kind of overkill, is congruent to the measure of angle 2. But what we're saying is that these two are the same angles. So this is 30 degrees, this is 30 degrees. Now, another way you can do this, all right, in geometry, let's put our little arcs like this. This represents an angle, is by using a little hash mark like this. One little line and this little line like so, okay? So notice this has one little line, this has a little line. This is indicating that this angle is the same as this angle, all right? So let me give you some more examples, what that would look like, okay? All right, first of all, let's just kind of talk about congruency again real quick. So let's say I have a triangle and I have another triangle. I'll get back to the angle thing here in a second, all right? So how do we represent triangles? Let's go ahead and just do this real quick. So this is A, B, C. Let's call this D, E, F. All right, so this we can call triangle ABC. Excuse me. All right, so it's triangle ABC, and this is triangle DEF. DEF. That's how we do this in geometry. And you could write this as triangle FED. As long as you're doing it in the correct order, or your starting point, FED, okay, that's fine. All right, so EFD, you kind of get the idea, right? As long as the letters are in kind of the appropriate order, that's the main deal. And then you draw a little triangle in front of it, okay? So if these are exact same triangles, we can call these guys here exact same size and angles, all right? So for example, this angle and this angle are the same. Boop. Okay, we'll draw a little line like that, meaning that these angles specifically are the same. And then let's go with these angles. These two angles, we'll put two little marks because this angle, let's say, is different than this angle, right? Unless this is an equilateral triangle, then that's a whole nother story. But we're saying this angle is exactly the same as this angle, so we'll put two little marks like so. And then you guessed it, if these angles right here, we got 1, 2, 3, 1, 2, 3, okay? So that's, you could see that I'm saying that this angle is the same, this angle is the same, this angle, and this angle is the same. Now, how about the sides? Well, let's say this side is the same as this side in length, okay? And this side, these two sides here are the same, and then these three little marks, hashes here, indicate that these lengths are the same. Okay, so you could kind of, let's say AC is the same measure as DF. So you could say AC, if you think of this as a line segment, is congruent to DF, line segment DF. All right, so congruency, very, very important concept in geometry, and this is you know, how you'll see it as a symbol, but you also see this notation like so, okay? All right, so that is congruency and triangles real quick. Let's kind of talk about something that's kind of like congruency, but it's called similarity, all right? So let's take a triangle, and now let's do a kind of bigger version of that triangle. So let's say this is A, B, C, D, E, F. All right, so this is triangle A, B, C, and this is triangle D, E, F. Now, if you look here, this triangle and this triangle, these are not congruent, okay? They're not congruent, right? Congruent is the exact same size and shape. But here, okay, our angles do appear to be congruent, right? So this definitely appears to be the case that the triangles themselves are in fact congruent, right? So you got here and here, and then you got some other things kind of going on, right? So these triangles do have the same angles, but they don't have the same lengths, all right? So in this kind of situation, you kind of have a zoom in. It's like this. It's like you copied and paste this, but you kind of, you know, this is like a zoom in version of it, or you kind of, you know, expand this, right? So this concept here is illustrating something called similarity, all right? So it's only one squiggly line. So it means that basically these shapes are in proportion. All right, same angle but different size. So if you want to indicate that, you just draw that little squiggly line. Okay, very, very big concept in geometry. So you don't want to confuse congruency with similarity. Okay, now again, I'm not going to get into how do you solve problems when you involve similar triangles or similar shapes, etc. Really, what I'm focusing on here is the notation and symbols. Of course, there's a lot, right? And I'm probably, I'm going to be missing a lot. Okay, well, hopefully not too many, but I'm trying to cover the big major ones in geometry. Okay, so let's move on. So that's we covered angles, triangles, congruency, similarity. So let's just talk about quadrilaterals here for a second. So, like, let's say I have a parallelogram like this, A, B, C, D, okay? So, actually, let me draw this a little bit bigger, all right, because I want to talk about some other notation. All right, so a quadrilateral, A, B, C, D. All right, so what we're going to be talking about here is quadrilaterals or polygons, right? So polygons. So a polygon, without getting all technical and stuff, but basically they're closed-in shapes, all right? The first one is a triangle. And then basically there's different types, convex and concave polygons. But basically what I want you to think of when you hear the word polygon is shapes that we can construct with like lines, okay, that all kind of connect, all right? Not like this, all right? Those are some lines put together. They all have to kind of connect in. So like this, okay, this is a three-sided polygon, this is a four-sided polygon, and you get the idea. This is a five-sided polygon, etc., right? So this is what we call a triangle. This is a quadrilateral, right? This is a pentagon, like the military building in Washington, D.C. So quadrilaterals are a huge part of four-sided polygons are a huge part of geometry, and we have various type of quadrilaterals. Okay, you have parallelograms, you have things like this, right? Like trapezoids, rhombus, there's squares, rectangles, all this kind of good stuff. We're not going to go into all of this. There's just too much to talk about. I'm just trying to hit some of the big concepts. So here is a quadrilateral, but specifically this is going to, I want to represent this as a parallelogram. Okay, so we just use this little shape like this. It's a little parallelogram shape, and you guessed it, we're going to write this as parallelogram A, B, C, D. Okay, now the interesting thing about parallelograms is that their opposite sides are congruent. Okay, so we already talked about that concept of congruency. So these two sides are the same measure, and these two sides are the same measure. Okay, now another thing about parallelograms is that their opposite sides are also parallel. So I'm going to kind of give you some notation for parallel, and we'll talk about parallel and perpendicular more in a second. So parallel, we can indicate that by this little arrow like this. If we put a little arrow like that and another little arrow like that, this is indicating this line and this line segment, these two here, okay, are parallel, right? So basically the idea of parallel is like two train tracks, they're never going to cross, right? So this would be like parallel lines. Now another way we can indicate parallel lines, let's say I have line L and line M and they are parallel to one another, they're never going to cross. I could just say L is parallel to M. Okay, so this is a very common way of writing this. If I'm calling this line L and this line M, I can do it this way. But on a figure, all right, this is the way you would see that. Now, these two sides, these opposite sides here are also parallel. Now, I would not put just an arrow like this because what I'm saying is that this is parallel to this, and it clearly isn't. So we have to put two little arrows like so, okay? All right, so again, a lot of notation. By the way, Another interesting thing about parallelograms is their opposite angles are congruent. So how would I write that? So this angle and this angle is congruent, meaning that they're the same. So I can go like one little hash mark like that. That's indicating these two angles are the same. And then these guys right here are the same. Now again, I used one little hash here, so I'm going to have to use two hashes like so. Okay, so I could kind of write this way. All right, this angle right here, how would I describe this angle? I would say angle, all right, angle ABC is congruent to angle ADC. All right, angle, whoops, I got to put a little angle in here. Angle ADC. All right, so congruency, you kind of get the idea. So in geometry, you do have different options. There's different ways you can express things, but you know, all the symbols and notations that I've covered so far are super, super common. You're definitely going to have to, know them. This is like, again, fundamental geometry concepts. Let's go into parallel lines and perpendicular lines a little bit more, okay? So let's say I have two lines again, and they are parallel. Let's just review that, right? So that would be L is parallel to M. So line L is parallel to line M, and you can have anything. You could have if I wrote AB like this, okay, that's line segment AB is parallel to line segment CD, okay? So it doesn't have to be lines, it could be anything that we talked about, rays, lines, you can compare any two things that could be parallel to one another. Now, let's talk about this concept. All right, let's say we have L. I could make a better L than that. L, and then we have M, okay? So what appears to be going on here? Well, they're obviously crisscrossing here. They're intersecting. But let's say I put this little symbol in, okay? Now, this is another important symbol that we need to know in geometry, this little kind of corner thing here, okay? So what does that represent? Well, this means that this angle here is 90 degrees, okay? That's 90 degrees, meaning that when two lines or anything, two line segments or anything that crosses and forms a 90-degree angle, we call this a right angle, okay? Right angle. So this indicates that these two lines are what we call perpendicular, right? So the notation for that is L. It's a little thing like that. Okay, it's like an upside down T. L is perpendicular to M, and this would be the corresponding figure to it. Okay. All right. So pretty much, these are just real basic fundamental type of concepts in geometry. And now let's go ahead and keep going. So let's talk about circles here for a second. So if I have a circle, that's a terrible circle. Let's see if I can get it a little better. By the way, years and years and years ago, I mean decades and decades ago, before there was all this computer stuff and whatnot, I had a math teacher, just a little side story, who was just absolutely amazing. She taught math in Romania, I believe. She had like a PhD in math, but in a heavy accent, which I thought was really cool. But she was able to, on a chalkboard, literally take a piece of chalk and draw the most perfect figures. And it was just always so crazy how she can just draw a circle, and she would kind of just like use her elbow and arm as like a compass, hopefully you know what a compass is, right? There's a little like pencil thing, and this kind of goes into the paper, then you swing it around and you make a circle. Anyways, Mrs. Weebus, I believe her name was, but she was like 100% perfect circle and figures, and to this day it sticks with me. So anyways, as a math teacher, you strive to try to draw. You get better over time, but I mean, there are just some people out there could just draw like perfect shapes. Anyways, here's my circle. So in a circle, I have a point, okay? This would be called the center of the circle. So we can just call that circle A, like so, okay? Now, in a circle, we have angles, okay? We have diameters, radius, and whatnot. So generally here, we're just going to use points. We're going to use the same notation. So let's say we have B and C, and we're talking about this part of the circle, okay? Well, let me get back to this angle right here, okay? So if I'm going to talk about this specific angle emanating from the center of the circle, I'll just use the same notation, angle BAC. Got to be careful, right? Because we're talking about it's going from BA to C. But what about this part of the circle? How about this little outer part, okay? Well, this is an arc, all right? We call this an arc. And this would be arc BC. We kind of do it like that, like a little arc deal, a little type of thing like this. So, but in circles, there's a lot of going on. You know, when you're studying circles, you have circles, you'll have lines that are passing through circles, and there's all kinds of properties and whatnot. But generally speaking, and I'm certain that I'm probably missing some notation, but you got lines that are tangent, you got things called chords and everything else. But typically with circles, you're going to be using a lot of that same kind of notation that we were talking about with angles and line segments, lines, etc. Okay, so that'd be incorporated with it. But things like with arcs and whatnot, that would be a different type of symbology. Okay, there's a lot of things that definitely kind of, I'm sure I'm leaving out. Let's see here. What am I missing? Well, let's talk a little bit about basic trigonometry. Okay, so let's take a triangle like so. Let's call this a right triangle. Okay, meaning that here we have a triangle and this angle in the triangle is 90 degrees. So here we have different angles. We can call this angle X and angle Y. Okay. But when we're talking about degree measure, all right, in geometry, you start learning basic trigonometry, okay, what we call these trigonometric ratios, all right, and these look like this, like tangent, all right, of x degrees, sine of x degrees, and cosine of x degrees, okay? And all these and I'm not going to get into this, it's not the point of this video because this video is already kind of running kind of long. These are just ratios, okay? They're ratios. They're comparing two sides of the triangle here, okay? So this side of the triangle we call the hypotenuse. This side of the triangle right here is the opposite side, and this side is the adjacent side. So these this notation, okay, that a lot of you will definitely study more in detail in trigonometry, but you'll really start learning that in basic or in geometry, basic trigonometry. These are things that help us solve right triangle problems, okay? So in other words, if let's say I have a triangle and it's a right triangle and this is 30 degrees and this is, let's say 15 in measure, knowing this right here, just this, I can get this length and this length, and I can also get this degrees. So right triangle problems are super important, and it's the foundation to trigonometry, which you'll learn in geometry. So let me see here. I know I'm missing stuff, but I think I kind of covered a lot. Of course, I think the things that I did cover, the basic building blocks of how to represent an angle, congruency, symmetry, rays and stuff. You'll incorporate that in deeper study of triangles, etc. Of course, there's rotations and dilations and everything else. And yeah, you'll see that when you see that. But anyways, if you're actually still with me in this video at this point, one, thank you. I'm trying to again give you as much common symbology. But if you understand everything I've talked about so far, then that's pretty awesome. One last thing, I am talking about degrees here. That's probably something that I should mention. So an angle measure like this, all right, if I call this 30, we do use this little tiny little circle up there. Okay, that's a degree measure. Okay, so this means 30 degrees. But in mathematics, there's even other ways you can measure angles. Okay, degrees is the most common, but there's things called radians. There's even some other kind of crazy units of measure that, if you continue to study mathematics, you'll see. Okay, with that being said, let's go and wrap up this video. Again, geometry, huge topic, a lot of symbology, a lot of notation. So if you are confused about it or you kind of mix things up, and you have to be specific, you have to be precise. If you're putting down the wrong notation and symbols in your answers, you get those problems incorrect. So again, the whole purpose of this video was just to strengthen your understanding of it. And also, if you're new to geometry or going to be taking geometry, this is a good introduction to it. And if you're just curious, now you'll be able to, if you're walking down the street and you see some guy and he's got this crazy notation on his t-shirt, you'll be like, oh, I know what that is. Of course, I'm trying to be funny. Maybe I should stop trying to be funny and wrap up this video. So with that being said, again, I'm going to leave a link to my full geometry course in the description of this video, along with my learning program. So hopefully, this really, helped you out in some way. But with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.